Welcome, my name is John Edwards.
And I'm Kesra Mansouri.
And tonight we're going to be talking to you about Titan, one of Saturn's moons, and its potential to harbor extraterrestrial life.
To begin with, we would like to provide some information about Saturn. It's the second largest planet in the solar system, and it lies at a distance of 1.43 billion kilometers, or 9.5 astronomical units from the Sun. This makes a long journey of 29 years for one orbit around the Sun. It is one of the gas giants and composed of mostly hydrogen and helium. In fact, Saturn's density is less than that of the water and floats. It has a diameter of 120,000 kilometers across its perimeter. Like Jupiter, it has a turbulent atmosphere and experiences major windstorms at its north and south poles. Saturn's rings are believed to have formed by collisions of moons and other celestial bodies that were captured by the planet during its formation. The two major gaps in the rings are called the Cassini division and the Encke division. Saturn has at least 62 moons that have been discovered, and the largest of them is a Titan, which we're going to be talking about further on. From the top image, you can see the solar system of our own solar system, with the Saturn is in the center. It shows that it's in the non-habitable zone. And at the bottom left corner, we can see that the Voyager spacecraft that was initially used to investigate Saturn and its moons.
Okay, so now going on to the characteristics of Titan itself. Titan is 5,150 kilometers in diameter, which is actually more massive than Mercury, making it the second largest moon in the solar system behind Ganymede, of course. It orbits Saturn approximately every 16 days or so, which is about an average distance of 1.2 million kilometers. The surface temperature of Titan is a bone-chilling negative 179 degrees Celsius. Despite this, Titan's atmosphere is 60% thicker than the Earth's own and consists of mostly nitrogen, methane, and hydrogen gas. Its rocky core is mostly nitrogen, and surface pressure is about 1.5 times that of the Earth. In a sense, Titan and Earth share some striking resemblances. It has this dense atmosphere and has geological features such as mountains, rivers, and lakes. However, so many lakes contain liquid methane and ethane, which is also known as natural gas, so you definitely wouldn't want to swim there. Liquid methane is also a major component of Titan's atmosphere and precipitation cycle. Large raindrops and flash flooding are responsible for the eroded hydrocarbon landscape of Titan. In fact, deep river channels and eroded basins indicate fluvial activity, also known as river basins. The surface itself mainly consists of a mixture of water and hydrocarbon ice, which will be a major proponent for life if it's found to exist on Titan. So in the images you can see the rocky core, nitrogen core of Titan, and the individual layers up into its thick hydrocarbon atmosphere. And below is the size comparisons of Earth, Titan on the lower left, and the Earth's moon on the upper left, which, comparing the sizes, it's about much smaller than Earth, but still could harbor life. And then to the right is the precipitation cycle that exists on Titan, much like the Earth's, except that it would be methane, liquid methane rain instead of water.
Now I'm going to talk about Cassini and Hume's spacecraft. Cassini and Hume's spacecraft was the spacecraft which arrived amongst the planet in October 2004. It captured striking images of Saturn and new discoveries were made. The probe landed on Titan in January 2005. Upon entry into the hazy upper atmosphere, the landscape was found to be much darker than originally expected. Small rocks dot the surface along with many of the liquid methane lakes, and one discovered to be larger than the Lake Superior. Regino, discovered later in 2005, is a feature of volcanic roots that could contain water and dry ice. It also discovered that methane exists in solid, liquid, and gas states on Titan. On the left side, we see the image of Cassini-Hughes spacecraft, and in the middle, we see the image taken by the Cassini spacecraft that shows methane rain that is happening on a specific surface area. And on the right side, we can see the methane lakes as blue on the landscape. In this image, which was also taken by Cassini and Hughes spacecraft, that was taken while it was initially descending down to the surface of Titan. At the top layer, we see east, west, north, and south as it descends from atmosphere to the ground level. As you can see, from top to bottom, we see the hazy atmosphere that consists of very thick and dense methane-based atmosphere. And as it descends, we also see that the riverbeds and the mountains that's an evidence of liquid state rivers that is actually happening in the Titan.
Does Titan harbor life? Well, let's take a look at this. If life does exist on Titan, it would be extremely different from life on our own planet. However, understanding the hydrocarbon precipitation cycle on Titan could be vital for figuring out how life first developed on Earth, when the nitrogen atmosphere lacked oxygen. For example, hydrocarbons have ionic properties that allow other molecules to attach to them and form basic life forms. Titan contains all the ingredients for life to exist, as we know: hydrogen, oxygen, nitrogen, and carbon. And the hydrocarbon lakes may very well host microbial life, but definitely not any kind of form of intelligent life, as we know. Unlike on Earth, though, organisms would inhale hydrogen and exhale methane instead of inhaling oxygen and exhaling carbon dioxide. And the image below, we see this futuristic-like view, but it's real, of what the surface of Titan actually looks like. And even though the Cassini spacecraft discovered a lot of things about Titan that we had no idea about before, NASA's still talking about some future missions to the moon, and even some other Saturn's moons that might be of interest. But there's still so much we have to learn about it. 2 proposed missions to Titan, which wouldn't even happen until the late 2020s, they give a chance for further development of this already known scientific data. The Titan-Saturn system mission, for example, is proposed to launch in 2020 and would arrive in 2029. It would consist of an orbiter and 2 probes, one of which will be a hot air balloon performing aerial surveys of Titan's atmosphere and determining the chemical composition of it, and the other would sail the seas, methane seas to be exact. Similarly, the Titan Mare Explorer, also known as TIME, will land on Ligia Mare, one of Titan's largest lakes, covering 100,000 square kilometers. This mission would depart in 2016 and arrive in 2023, and will study organic compounds, the atmosphere above the sea, cryovolcanoes, which are pretty much volcanoes that spew ice instead of lava, and ultimately the possibility for life. Future missions present a chance to discover different forms of astrobiology, and this would make Titan an important world in our solar system for the search for extraterrestrial life. And to the left, we have the Saturn system mission spacecraft with all of its high-tech gear and data that it would collect as it would explore. And to the right, we have the hot air balloon, which is also part of that mission, and the Titan Mare Explorer, which is sailing the seas.
Thank you very much for listening to us. I hope you enjoyed it.